Hello everybody. Today I'm going to talk about some important and some elementary option in Plaxis. That's why I give the name in this video as an introduction to Plaxis. In this video, you will learn, you will know every option that are built in Plaxis. So I will try to introduce this option step by step. So now I am going to share my screen. Okay. So this is my Plaxis software. It's a Plaxis 2D Ultimate. So from soil, so we can start from the soil options. There's some model building steps as a soil structures, mesh, flow conditions, stress construction. So in the soil option, either we can create some soil layer with the create borehole option. So here we can find the position of the borehole and hydraulic head. And in the add option, we can add the soil and assign the material. Okay. So with this, we can create soil. The other properties here is the material set. So in the material set, we can create the soil by clicking here in new. And there is some basic properties in soil. In the Plaxis, they call this as general properties, mechanical properties, groundwater condition, thermal properties, interface, and initial. So in the general properties option, there is a three option. This is called the material set, unit weight, void ratio, and rectangle. Basically, material set and unit weight is most important and most useful. Here is you can give the name here and you can select some soil model, the Mokulum model, to Wake Brown model, and some other known and popular and also unknown models here. So we can also create an unknown model to select the user defined. So in the second option is drainage type. So this the drainage type, either the soil can the drain or undrain, but also non-porous. But in Plaxis, they actually give other three and then properties and then A, B, and then C. So we'll discuss on it in later. And then we can select the color here. Then the most important thing is unit weight. So first the unit weight is unsaturated unit weight, and second one is saturated unit weight. So we can also input the void ratio here. And then the most important thing is mechanical behavior. So we can give the mechanical properties of the soil by importing the value in stiffness like Young modules, Poisson ratio. So if we input the Young modulus and Poisson ratio here, the all alternatives, depth dependency and wave velocity could be generated, or we can import this value here. In the strength parameters, so in soil strength parameter, this is shear strength and depth dependency and also the tension. So in the shear strength, so you can import here the cohesion, friction, and balancing. In the depth dependency, we don't need to import here, it could calculate automatically. And the tension also, if we want to give the cut properties or tensile strength, we can give the manually set here. The next option is groundwater. So there's some groundwater model built in here. This model classification is standard, hypers, USD, steering, user defined. So the hypers model, this hypers model is actually for the European soil, and this is for the soil and water content curve. And there's a option for your model, Van-Gutachten and approximate Van-Gutachten. Also in this option, we can select the soil as subsoil or topsoil, and soil classification standard. We can give the soil size, coarse, medium, fine, very fine, or organic. In the soil option, we can the size of the soil. So it's only two portion is less than 2 micrometer, and another option is 2 micrometer to 50 micrometer diameter and size. In the flow parameters, so permeability, either here we can give the horizontal permeability or the vertical permeability Ky, or we can use the default permeability value if you don't have any permeability value. So, and then porosity and then unsaturated zone. So we can import here, or it can be set as a default value. In the thermal option, so we can give the thermal diffusion properties, thermal strength properties in freezing and thawing, and freezing and thawing depend on the making freezing or unfreezing options in the ground. So in the vapor diffusion, we can also use this portion. So in the interface, in properties, in stiffness, so stiffness can be determined from derived option or cannot direct. Also in the strength, we can model the rigid, or you can use your manual. In the groundwater, you can use cross permeability, impermeable, semi-permeable, or fully permeable. Even in drainage conductivity, you can import here. Also in the thermal option is here. In the initial stage is KO determination. So KO determination is automatic, or we can put as a manual. So we have to put this value here. So this was the important part of soil option. So now I'll move the structure. So in this area, we can create the soil polygon. So here we can create a soil polygon either clicking the point, or create a soil rectangle, or we can cut a polygon here. So even if we want to create some load or point, something like that, even we can create here some lines, poly curve or something like that. Then yeah, there is another option is you can also import the geometry. Yeah, and in this option, we can also modify the coordinate value of this polygon, like the XY position. So do not need to be scared during the drawing. You can also modify later on, but we should care always what we do here. We need to save it. And then the other option is mesh. So in the mesh option, actually you can create mesh. So click here, and there is a element distribution option is fine, very fine, coarse or very coarse, and the other option is theirs. And then when you click this option, view mesh, you can see the original mesh. So the next option is flow condition. This is most important uh, stage in model generation or model development. So this is the initial phase. So initial phase, so model, so it's represent the model in the initial phase, initial stage of calculation. So there are some calculation types. I will discuss all types in later video. But there's a KO procedure, field stress, gravity loading, and flow only. And for this type of loading, we also be ensured that the pore water pressure calculation type. But so this is the parent phase. In the child phase, there's another option. Here, plastic consolidation, dynamic, and fully coupled flow deformation is static and dynamic with consolidation. Also, this option, we have other parameters. So to know these all option how it's work, we need to discuss again. So this is the flow condition for the phase explorer, but a very important option there is model explorer. So in the model explorer, first parameter is attribute library. In the attribute library, so for calculation the earthquake and seismic loading, so we need to use this dynamic multiplier. In the area option can go, and there is a displacement multiplier, load multiplier. The displacement multiplier can add the some seismic model, either a harmonic or tabular. If you use this tabular option, you can import this file, or you can click here to create model here, or you can use the harmonic and then keep the phase and amplitude and frequency, then it will automatically produce a model here, and also in a same as a load multiplier. So for the flow function option, so you can use this as for the groundwater elevation or groundwater fluctuation or groundwater stress. In the next option is the discharge function. With this discharge function, you can import the discharge value with the time, like it all are is time variant. Here also head function is also time variant. You can tabular, linear, or something like that. Yeah, so delete this one. And the next one is thermal function. Thermal function is similar like that. The heat flux function and transfer function, same as this previous one. So these three options. So now we are moving to the material. So we already discussed about the soil here. In all soil properties that actually we input in the previous soil option. So that is actually here. So all are the metal set, unit, weight, water ratio, everything is here. Okay. So now water level. There is a two water level here. For one is borehole water level, and another one is user defined water level. So borehole water level, actually borehole water level we already used in the soil option here, and the user defined option, we create user defined option here. You can click here, click here, and then create water level. Okay, create water level from here, or modify water level here. So now geometry. So in geometry, we have only one thing is here, polygon. There is no line here. And then the groundwater flow condition. So this one is groundwater flow condition. In the groundwater question, actually, this is called as Neumann boundary condition. So in this area, we can import this value if we like. Sorry, I'm not like this one. I click here, like I want to use this as a boundary condition, then I can select here seepage, infiltration, or something like that. This is not actually depend on now with not with the hydraulic is flow and not flow infiltration, something like that. And the soil. So we can get every data from that we already previously inputted the soil option. So now most important things in the Model Explorer is the model condition. So in Model Explorer, you can see the climate. So in the climate option, you can import all air temperature, surface temperature, or surface transfer. It can depend on constant or time dependency. So it can vary time to time. In deformation. So deformation actually, this is the deformation boundary condition. How actually your model, like in the boundary, is like normally fixed or free or horizontally fixed, vertically fixed or free fixed. So yeah, so all these we can change here in the dynamic option. So for dynamic options, if we use the seismic loading or any vibration or earthquake, so this dynamic and this boundary condition is very important for us in the analysis. So there's a lots of boundary conditions here for dynamics: viscous, free fit, and tight degree of freedom. So now we are moving in the field stage. We can import here in field stage below in the groundwater flow. This groundwater flow actually mean discrete boundary condition is this is the boundary always close in the lower portion of the model. In the precipitation option, we can import the rainfall data. So it might be constant or in the dynamic or harmonic. So pseudo-static, if we want to analyze the peak ground acceleration, so we can import the peak ground acceleration pseudo-static seismic loading, the thermal flow. We can also input the thermal condition of soil here or the environment. Then the water is very important. So we already created user-defined water. That actually we select here user-defined water or borehole water. We can select from here, or if we can create another water level, we can also select from here. It's depend on the face-to-face, which phase you want to use, which water levels you can select from here. So that was the very most important things in Plaxis is the flow condition. Now is stress construction. So in stress construction, this is basically, so we can calculate the model, and then if we want to see the model, we have to click the view calculation result. So in the initial stage or beginning stage, I think this is all are important things. If we can give the value or the data properly in the Plaxis software, we can get a good result. So I think this tutorial was very important, and we learned something from here. If we want to we- so I'm stop share my screen. So from this we all learn the options are available in Plaxis. In the next video, I will try to show the analysis in Plaxis or other important option that I already mentioned in this video. Thank you for watching video. See you again. Bye.